Every single major automaker in the world builds its newest electric vehicles in a brand new facility, a purpose-built megafactory out in the countryside with room to expand. Porsche did the opposite. They took the most technologically advanced car assembly line on the planet, crammed it into the middle of a city neighborhood surrounded by apartment blocks, buried it 4 stories underground, ran a conveyor bridge over live traffic, and somehow made the whole operation carbon neutral before the first car even left the building. And the most remarkable part? They built all of it without stopping production of the car that built the entire Porsche legend. The 911 never missed a single day. That address is Porscheplatz 1, Stuttgart-Zuffenhausen, Germany, a postal code that has meant something since 1950. And what happened there between 2016 and 2019 is one of the most extraordinary feats of industrial engineering in modern automotive history. To understand why Porsche chose to stay in the city rather than leave, you have to understand what Zuffenhausen actually is. It is not an industrial park. It is a residential neighborhood in Stuttgart, a mid-sized German city nestled between hills, famous for its vineyards, its traffic, and the 2 automakers that have called it home since the early 20th century. The factory sits at the center of it all. Apartment buildings on 3 sides. A 4-lane public road running straight through the site. No available land to expand outward. The only direction left was down. And so that is exactly where Porsche went. The decision to build the Taycan, Porsche's first fully electric production car, at Zuffenhausen rather than elsewhere was not purely sentimental. It was a statement. The same hands that have built every 911 since 1964 would build the car that was supposed to define the next 60 years. But that decision came with a price tag and a challenge that would have made most companies walk away. The total investment in Taycan electric mobility, production facilities, and the jobs created around them exceeded $6.5 billion. An additional $270 million was poured in during 2023 upgrades alone. And to make any of that work, engineers first had to figure out how to add 62,000 square feet of factory floor to a site that had no room left on the surface. The answer was to go 82 feet underground, 4 floors, excavated beneath a working factory while that factory kept building cars above. Let that sink in for a moment. While 911S rolled off the line on the surface, construction crews were digging 8 stories below their feet, installing structural foundations that had to carry the weight of a completely new manufacturing complex without disturbing a single production shift above. The project took approximately 3 years. Every piece of heavy equipment had to be carefully coordinated around live production schedules. The logistics alone were a years-long puzzle. When the dust settled, Porsche had created something that does not really exist anywhere else on Earth. A multi-story electric vehicle factory embedded inside a city, connected to surrounding buildings by a conveyor system that literally crosses over a public road 65 feet in the air, and certified to Germany's highest green building standard before it ever produced a single vehicle. Now, here is how a Taycan actually gets built inside this place, because the process is where things get genuinely fascinating. It starts with steel. Raw coils of high-strength steel arrive at the body shop, where precision stamping presses cut and form every major panel: the floor sections, the door skins, the roof, the quarter panels, the structural frame elements. The Taycan body is a sophisticated mix of steel, aluminum, and high-strength steel alloys, each chosen for its role. The heavier structural sections use ultra-high-strength steel for crash protection. The outer skin panels use aluminum to save weight. Getting those 2 materials to sit cleanly next to each other requires bonding methods that would not have existed in a mainstream factory 20 years ago. Adhesive bonding, flow drill screws, and laser welding all working in combination. The body shop runs almost entirely automated. Banks of articulated robotic arms line both sides of the assembly jigs, their movements choreographed to within fractions of a millimeter. Sparks drift from welding tips as the white body, what the industry calls a body in white before any paint or components are added, takes shape on its fixture. A fully assembled Taycan body in white weighs roughly 770 pounds, and it takes hundreds of individual weld points, adhesive joints, and fasteners to hold it together at that number. Here is something most people never think about. Every single panel gap you see on a finished Porsche, the space between the door and the fender, the hood and the front bumper, has to be controlled to within half a millimeter, consistently across thousands of cars. At high volume, that kind of precision does not happen because skilled workers measure each one. It happens because the body shop fixtures, the clamping systems, and the robotic welding cells are calibrated so precisely that the geometry repeats itself every single time. Once the body is complete, it moves to the paint shop. And here is where the overhead conveyor system comes into play. The one that runs nearly 3,000 feet through and between Porsche's various Zuffenhausen buildings, crossing 65 feet above a 4-lane public road in Stuttgart. Painted Porsche bodies literally ride in open air above city traffic. If you happen to be driving through that part of Stuttgart and you look up, you might catch a glimmer of silver or guards red floating silently overhead. One of the stranger and more spectacular sights in industrial Germany. The paint process itself is a multi-stage operation that takes the better part of a full day. The bare metal body first goes through a phosphate bath, a chemical pre-treatment that cleans every surface and creates a microscopic crystalline layer that gives the first coat something to grip. Then comes the cathodic electrode deposition coat, better known as E-coat, where the entire body is submerged in a tank of electrically charged paint particles. Because the body itself carries an opposite electrical charge, paint is drawn uniformly into every seam, cavity, and interior surface, places a spray gun could never reach. That E-coat layer is the car's primary corrosion barrier. After the E-coat oven, the body gets a sealer applied to every weld seam and hem flange to block any possible moisture path. Then the primer coat, then the base coat, the color layer, then the clear coat. Each layer is baked in a separate oven. By the time a Taycan body exits the paint process, it carries roughly 22 pounds of paint alone, in layers that together are thinner than a human hair when measured individually, yet form a finish hard enough to survive decades of road use. And then comes the part that makes the Zuffenhausen factory unlike any other assembly plant on Earth. The body moves onto the Flexi line. Porsche was the first automaker in history to run automated guided vehicles in continuous automotive flow production. Before the Taycan, every major car factory in the world moved vehicles through assembly on a fixed conveyor, a belt or chain embedded in the floor that pulled cars through at a set pace. Every station worked to that rhythm. If one station fell behind, the whole line slowed or stopped. The conveyor controlled everything. Each Taycan moves through the assembly hall on its own autonomous platform, a low-profile, battery-powered automated guided vehicle, roughly the size and shape of a large pallet that carries the car body from station to station. These platforms navigate using embedded floor magnets and sensor systems, and they can be instructed to speed up, slow down, take alternative routes, or hold position at any given station without affecting the car in front of or behind them. If a particular station needs extra time, say a complex wiring harness is being routed, or a technician needs to recheck a torque value, that one AGV simply waits. The rest of the line keeps moving. Around 50 additional supply AGVs feed parts and components to the line, bringing exactly what is needed to each station at exactly the right moment. The system was commissioned in just 4.5 months, an almost unbelievable timeline for a technology that had never been deployed at this scale in automotive production. By 2024, Porsche had deployed an upgraded AGV fleet running MHP Fleet Executor software, with a projected 20% improvement in logistics efficiency across the floor. The flexibility goes beyond time management. The Flexi line can mix different vehicle variants on the same loop without any reconfiguration. Different trim levels, different powertrains, different option packages, each AGV carries the build data for its specific car, and the line routes it accordingly. Porsche has since applied the same principle to its 718 sports car line, where combustion engine and fully electric versions now run side by side on AGVs in the same assembly hall. Something that would have been structurally impossible with a traditional conveyor system. As the Taycan body moves through the Flexi line, the interior goes in first. The dash assembly, the center console structure, the wiring harnesses, those harnesses alone are among the most complex components in any modern vehicle. The Taycan's electrical system has to manage everything from the infotainment cluster, to the battery thermal management, to the regenerative braking system, to the multiple charging modes. The harnesses that carry all of that run throughout the entire vehicle and can take highly trained technicians the better part of 30 minutes per car to route and secure correctly. Then come the headliner, the carpeting, the pedal assembly, the steering column, and the door panels. At this stage, the car is upside down in the installer's mind. It is a hollow shell being filled from the inside out, with workers positioned on platforms alongside the AGV, reaching in through the door openings. The sequence matters enormously. Some components, once installed, make others impossible to reach. The build sequence for a Taycan was engineered not just for speed, but for access. The order in which every part goes in was mapped and validated long before the first production car was assembled. Now, while all of that is happening in the main assembly hall, something equally remarkable is being built in a separate facility and prepared for what engineers call the marriage, the moment the body and drivetrain come together. Because the heart of the Taycan is unlike anything that has ever been assembled at Zuffenhausen before, the battery pack. 439 pounds of it. Most electric vehicles on the road today run on a 400-volt electrical architecture. The Taycan runs on 800 volts. That decision, made early in the car's development, changed almost everything downstream. 800 volts means the same amount of power can move through cables that are half the diameter and a fraction of the weight of their 400-volt equivalents. The copper conductors in the motor windings carry less current for the same power output, which generates less heat, and charging speed that was, at the time the first Taycan launched, simply not available anywhere else in the consumer market. On a 270 kilowatt DC fast charger, the Taycan can go from 10% to 80% charge in under 20 minutes. The 2025 models do it in 18. At a time when most EVs were still waiting 30 to 45 minutes for the same range restoration, that was not a minor difference. It was a complete rethinking of what an electric vehicle could actually do. The battery pack itself contains 396 lithium-ion pouch cells, arranged in 33 modules. Pouch cells are flat, flexible cells sealed in a laminated foil casing rather than the cylindrical or prismatic formats used by many competitors. They pack more energy into a given volume and can be stacked cleanly into a flat floor structure. The pack delivers a usable capacity of approximately 105 kilowatt hours, and it sits in a sealed, temperature-managed enclosure that runs the full length of the car's floor. Thermal management for that pack is its own engineering story. Lithium-ion chemistry degrades when it gets too cold or too hot. The Taycan's battery management system runs a dedicated liquid cooling loop through the pack. The same coolant circuit preconditions the pack before fast charging, warming it, or cooling it to the ideal window for peak charge acceptance. That preconditioning happens automatically when the driver sets a fast charger as a navigation destination. The car prepares itself before it arrives. Assembly of the battery pack happens with extreme precision. Each module is seated and secured. The intermodule bus bars are connected. The thermal interface material is applied between cells and cooling plates, and the entire assembly is sealed. Every pack is tested before it enters a vehicle. The electric motors, the Taycan uses two, one per axle. In the all-wheel drive versions, are built using a winding technique called hairpin winding. Traditional motor stators use round copper wire wound in coils around the stator slots. Hairpin winding uses rectangular copper conductors, bent into precise U-shapes and inserted into the stator in a densely packed, interlocking arrangement that looks, at the pre-assembly stage, remarkably like the bristles of a hairbrush standing on end. Because rectangular conductors fill the available slot area far more completely than round wire can, the stator achieves a much higher copper fill factor. More copper per unit of volume means more magnetic force per unit of current, which means more power and torque from a smaller, lighter package. The front motor on the Taycan produces up to 174 horsepower on its own. The rear motor produces up to 395 horsepower in the top Turbo S variant. Combined, the Turbo S makes 750 horsepower and hits 60 miles per hour in 2.4 seconds. The marriage of body to drivetrain is precisely that. A single, carefully choreographed moment where the fully trimmed body is lowered onto the combined battery floor and front and rear axle assemblies in one movement. Alignment pins guide everything into position. Structural bolts are driven to specified torque values. Electrical connectors are seated. From that point forward, the Taycan exists as a complete vehicle. The final stages of assembly include fluid fills, brake fluid, coolant circuits, washer fluid, along with wheel installation, torque verification, exterior trim, and glass. Every car then goes through a water leak test where it is subjected to a controlled spray equivalent to heavy rainfall to confirm that every seal, every window, every door gasket holds. After that comes alignment, software calibration, lights and electrical verification, and a rolling road test on Porsche's indoor chassis dynamometer, where the car is driven at simulated speed to verify drivetrain function, suspension response, steering behavior, and brake performance before it ever turns a wheel on a public road. And then something else happens. Because this is still Porsche. Completed Taycans are taken outside and driven on Porsche's own test track adjacent to the facility. A Porsche test driver puts every finished car through a series of maneuvers. Not a full race circuit evaluation, but a quality confirmation that no vibration, no noise, no unexpected behavior slip past the end-of-line checks. If anything is not right, the car does not ship. It goes back. Now, here is the fact that tends to stop people cold when they hear it. The factory achieved carbon neutrality in September 2019, the very same month the first production Taycan was delivered to a customer. The car and the building became carbon neutral on the same day. That was not a coincidence. Porsche planned it that way, and getting there required solving an energy problem that most manufacturers have not yet come close to addressing. The Zuffenhausen factory has run on 100% renewable electricity since 2017. Two on-site cogeneration plants, each rated at 2 megawatts, burn biogas derived from organic waste. They generate electricity and heat simultaneously, and because the process captures both outputs rather than wasting the thermal energy as exhaust, the efficiency of those plants approaches 90%. Carbon offsets cover whatever residual emissions remain from activities that cannot yet be fully decarbonized, bringing the net balance to zero. But the element that genuinely surprises people is the factory's exterior walls. The engine plant at Zuffenhausen has a facade clad in aluminum panels coated with titanium dioxide, a photocatalytic material. When sunlight hits titanium dioxide, it triggers a chemical reaction that breaks down nitrogen dioxide, one of the primary pollutants in automobile exhaust, into harmless water and nitrate compounds. A 126 square foot section of that facade performs the air cleaning equivalent of 10 trees. The factory that builds cars is actively neutralizing the pollution that cars produce using nothing but sunlight. That detail did not come from a marketing team. That is material science applied to a building envelope in a way that still has no real precedent at this scale in automotive manufacturing. The building also carries DGNB Platinum certification, Germany's highest green building rating, equivalent to LEED Platinum in the American system. The certification covers energy use, water management, construction materials, indoor environmental quality, and site ecology. Getting it for an industrial building of this complexity on a constrained urban site is exceptional. Now consider what all of this required in terms of human capital. When Porsche committed to building the Taycan at Zuffenhausen, not a single worker at that factory had ever assembled an 800-volt electric vehicle at production volume. Nobody in the world had. The technology did not exist at scale yet. Porsche hired 1,500 net new employees specifically for the Taycan program and trained every single one of them in processes that had to be invented alongside the car itself. 2,000 total new hires were associated with the Taycan launch. Multi-week training programs covered the new electrical systems, the AGV line procedures, the battery assembly protocols, the hairpin motor winding, the high-voltage safety requirements. A factory had to learn a completely new language while it was still speaking the old one, and none of it disrupted 911 production. Not for a single shift. The 2023 upgrades added another layer to an already complex site. A fully automated 2-story high bay warehouse, 35,000 cubic meters of storage capacity, holding 40,650 pallet spaces, was built to serve both the Taycan body shop and 911 production simultaneously. Every pallet moves robotically, no forklift drivers. Parts are called to the line by the production system and arrive exactly when needed, sequenced to match the build order on the floor below. There is also the question of what happens to the batteries that do not make it into production cars. During the pre-production development phase of the Taycan program, Porsche ran hundreds of test vehicles accumulating data, pushing batteries hard to understand degradation curves and failure modes. Those test batteries, retired from vehicles before the production launch, did not go to a recycling facility. They went to Porsche's Leipzig plant, where they were assembled into a 5 megawatt, 10 megawatt hour stationary energy storage system. That storage system is charged partly by 9.4 megawatts of on-site solar capacity at Leipzig. Pre-production test batteries became a power plant, a genuinely different approach to the life cycle of the hardware. By 2023, Porsche delivered 40,629 Taycan units worldwide, a record year, up 17% from the year before. The 2024 number came in lower, around 20,836 units, but that drop reflected a planned model year changeover to the next generation Taycan rather than any issue with production capacity. The factory has proven it can sustain high-volume output of a product that, as recently as 2015, did not exist in any form. The factory turned 75 years old in 2025. The first car built at Zuffenhausen rolled out on April 6, 1950. The 911 has been produced there continuously since 1964. And now the Taycan shares that address not as a replacement, but as a continuation of the same idea that the engineers and craftspeople at Porsche Platz 1 have been building toward for 3/4 of a century. Here is the question worth sitting with, and one that will define how every major automaker thinks about production over the next 20 years. The traditional conveyor belt has been the spine of automotive manufacturing since Henry Ford put one in at Highland Park, Michigan in 1913. 110 years of one idea. And Porsche walked into their most historic factory, ripped it out, and replaced it with a fleet of self-driving platforms that each know exactly where to go and exactly how long to wait. The line does not stop anymore, only the individual car does. If that model scales, and the fact that Porsche has already applied it to the 718 line, mixing combustion and electric vehicles on the same floor, suggests it absolutely does, then the next question is whether we are watching the last generation of factories ever organized around a fixed conveyor. Volkswagen Group has factories on every continent. Ford, GM, Toyota, every one of them still runs on chain and belt systems designed in the middle of the 20th century. So let me ask you this: if the AGV model eliminates the conveyor belt, eliminates the single point of failure, and lets a factory mix completely different vehicle architectures on one line without retooling, what does that mean for the next factory you never hear about being built? Is the death of the assembly line already in motion, and Zuffenhausen is just the first place it happened? Drop your answer in the comments. I want to know whether you think the AGV model eventually takes over every major factory, or whether the conveyor belt has one more generation left in it before it disappears. If you found this as fascinating as I did, hit the like button. It genuinely helps more people find this kind of content. Share it with anyone who thinks car manufacturing is just robots and sparks, because what is happening in Stuttgart is something much stranger and more interesting than that. Make sure you are subscribed, because the next one goes inside a facility where they make something even more ordinary, and the process turns out to be even more insane than this. Porsche did not just build a factory at Zuffenhausen, they made an argument that the most advanced manufacturing in the world does not have to be anonymous, does not have to be remote, and does not have to leave a mark on the atmosphere to prove it can compete. 75 years at the same address, 82 feet underground, 65 feet over a 4-lane road, the same hands, a completely different machine.